Alrighty, so today you guys are going to learn distance formula and midpoint formula. And I thought I'd throw this in there between teaching you guys transformations because you can actually use these formulas, more so the distance formula, to justify how a pre-image and its image, okay, preserve distance after you undergo a rigid transformation or a sequence of rigid transformations. Alright. So the distance formula is used to find the distance between 2 points, right? x1, y1 and x2, y2. And here is your distance formula written out. All right, you can almost interpret this as the changes in x coordinates squared plus the changes in y coordinates squared, and then the whole thing square rooted. All right. All right, so let's apply this. All right. Number 1 says find the distance between the 2 points on the graph. All right, and it looks like they're talking about this point and that point there. Alright, and because they're not labeled, I guess I'll just call these points, I don't know, they don't have to be alphabetically in order, but alphabetical order, but I'll call it XZ. Alright, XZ. I'm going to grab a spare sheet of paper here to show you just exactly what's going on, right? So it looks like number 1, alright, looks like X sits at -2, 3, or sorry, -2, -3. Alright, and I can almost treat this as my first set of XY coordinates. So X1, Y1. My first set of XY coordinates, and then Z sits at -5, 3, and I can treat this as my second XY coordinate. So X2, Y2. All right, you can kind of it's already foreshadowed what's to happen. You're just gonna plug these coordinates into the distance formula to find the distance between these two coordinates. All right. So what would that look like? Well, I'm not gonna write the whole, and I guess geometry it is good to be specific. But I'm not gonna write the whole thing here. Alright, but I know distance formula is my x2, which is -5 in this example, minus x1, which is -2, so -5 minus -2 squared, alright, plus y2, which is 3 here, minus y1, which is -3 squared. Alright, so let's simplify this. Alright. -5 minus -2 is the same thing as -5 plus 2, so that give me -3 squared, plus 3 minus -3 is the same thing as 3 plus 3, that'd be plus 6 squared. All right, and then we can of course keep simplifying this. -3 times -3 is 9, plus 6 times 6 is 36, plus 36. All right, so the distance between x and z, all right, the distance would be 45 square rooted, the square root of 45. All right, and the reason why we leave it at that is because if we actually did that, 45 square root of 45, it'd give you this long nasty number, right? So we just keep it at the square root of 45. So the distance between those 2 points is the square root of 45. All right, and that's all we leave it as. All right. So the same thing applies whenever you're given 2 points, right? You can still use this formula here, right? And I'm gonna go ahead and fold this sheet of paper just so I have some extra space, so you guys can see. All right. It says find the distance of AB given A is at -4, 1. So A is at -4, 1, and B is at 3, -1. All right, again, we apply the distance formula here, and this would be my x1, y1, and my x2, y2. Just apply the distance formula. All right, I guess I'll bring it up here so you can see the distance formula. X2, which is 3, minus x1, which is minus -4 squared, plus y2, which is -1 here, minus y1, which is 1 here, minus 1 squared. All right, and again, if we simplify this, 3 minus -4 is the same thing as 3 plus 4, so that would be 7 squared, plus -1 minus 1 is -2, so -2 squared plus -2 squared. And if we simplify further, 7 squared is 49, plus -2 squared, which is 4. All right, so then we get that the distance between A and B is 53 squared. All right, 53 squared. All right, and that's what we put down here. The distance is 53 squared. Or I'm sorry, not squared, the square root of 53. Sorry, square root of 53. Square would be like a little notion, like the little 2 at the top. All right, I meant to say square root, the square root of 53. All right. And then I'll leave 3 for you to do on your own. All right, you should be able to do 3 after those first 2 problems. All right, But now let's look at midpoint. All right, I'm gonna go ahead and fold this one more time to give us some space. All right, let's look at number 3, or not number 3. Midpoint, number 4. All right, so the midpoint, as you can assume, the word midpoint is used to find the midpoint between 2 points. All right. And here's the formula here. All right, and before we move on, the midpoint formula is actually just a set of it's a set of coordinates, right? So once you plug in x1 and x2 and you divide it by 2, right? You add these, divide by 2, you'll get your x coordinate. All right, so you can almost imagine this would be your x coordinate. And then once you add your 2 y values, or your 2 y coordinates, you divide by 2, it'll give you your y coordinate. All right. So your midpoint, the formula is really just a x y coordinate, right? It'll give you your x y coordinate for your midpoint. All right. So how do we actually do that? Well, it says number 4, find the midpoint of segment GH given G is at 7, -5, and H is at 9, -1. All right. So G, all right, this is number 4. G is at 7, -5, and H is at 9, -1. All right, let's plug in the formula. All right, so x1, and again I can write this x1, y1, x2, y2. All right, so x1, which is 7 here, 7 plus x2, which is 9, divided by 2. All right, y1, which is -5. All right, plus -1, which would be -1, right? Plus -1. All right, divided by 2. All right, and we can simplify, okay? All right, 7 plus 9 is 16. All right, over 2, and then -5 plus -1 is the same thing as -5 minus 1, which is -6 over 2. All right, so the midpoint, right? The coordinate, all right, your midpoint coordinate of segment GH, all right, would be 16 divided by 2 is 8, so it'd be 8. All right, and -6 divided by 2, 8, -3. All right, so that would be your midpoint of segment GH. So the midpoint would be 8, -3. All right, that's all it would be. All right, so you should be able to do number 5 now that I just showed you how to do number 4. Okay, using just plugging in. Alrighty, so on your back page, all right, you have find a missing endpoint. All right, so I'm assuming they're gonna give you the midpoint of a segment, and they'll give you one endpoint, and you're responsible for finding the other endpoint. All right, so let's think about what's going on. Number 6. Okay, number 6 says find the coordinates of point A if M -1, 2 is the midpoint of segment AB, and B has coordinates of 3, -5. Or excuse me. So let's just do this. Let's visualize this first before we do it. All right. So, and of course this grid isn't going to be to scale, but you can almost assume, okay, it will look like this. The midpoint's at -1, 2. So -1, 2. So it'll be like right here. All right. -1, 2. All right. And that's M. All right. And B is at one endpoint. B is at 3, -5. So 3, -5 put us like somewhere down here. All right. And that's 3, -5, and that's B. Okay, so they want us to find the other endpoint, A, and you can assume A is gonna have to sit up here, because if that's the midpoint, obviously you wouldn't go that way again, you'd just go up here. So A is gonna sit somewhere up here, and I don't know where, but I can assume it'd be somewhere up there, right? It's gonna be equal distance from M as much as B is. All right, but how do we do that? All right, and I'm here to tell you, well, you're going to use the midpoint formula to help you find the other endpoint. All right, so excuse me, my allergies are kicking in. All right, so we know, and I'm going to write number 6 here, we wouldn't get lost, that the midpoint is equal to x1 plus x2 divided by 2, and y1 plus y2 divided by 2. And remember, this is just gonna give you, the midpoint gives you an xy coordinate, right? That's what midpoint is. It's going to give you an xy coordinate. All right, so So essentially what's going on here is we're just going to plug in. We're going to plug in to find the other endpoint, all right? And remember, to find the midpoint, you have to plug in, all right, xy coordinate and another xy coordinate, all right? So what does that mean? Let's break down what's happening here, all right? So I know that this, right, this is going to give me my x coordinate. This whole equation, right, is going to give me my x coordinate, and this whole equation here is going to give me my y coordinate, all right? But we know what this whole thing is going, this fraction is going to equal to, okay? We know it. It's going to be equal to -1 because that's my midpoint. My midpoint, it tells me right here, is -1, 2. So I know that this whole thing, we know that the whole thing is going to equal -1. And the same thing here. We know that whole second piece is going to equal 2. All right, because again, this is my midpoint, but they have already told us my midpoint. I already have coordinates for that, so this would equal 2. All right, so I guess you can already see I'm foreshadowing what's about to happen. Well, look, we already have a x2 y2. All right, we have a x2 y2 coordinate. All right, so I can just plug those in to find my other x1 and y1 coordinate, which would be my other endpoint. All right, so if I come over here, and I plug in x2, which is 3 here, and I plug in y2, right, which is -5 here, -5, I'm going to put that in parentheses. We can just solve this now to get my x1 and y1 coordinates, right? So how do I get this 2 off of this fraction? Well, remember, I just multiply by 2 on each side, multiply by 2, all right? And I get x1 plus 3 equals -2, all right? And then I just subtract 3 on each side, and my first x coordinate, my x1 would be -5. All right, and the same thing here. All right, I get this 2 off. I'm gonna separate this so you don't get confused by multiplying it on each side. All right, and I get y1 plus -5 equals 4. All right, and remember, plus -5 is the same thing as a -5, right? So I could just write y1 -5. All right, get rid of that other parenthesis, and then I just add the 5 on each side. And I get y1 equals 9. And look at that. We just found the other endpoint. All right, the other endpoint. So A would be at, right, -5, 9. All right, and you can almost visualize that. -5 would be like here, and the 9 would be all the way up here. And look, it put me on the other endpoint. All right. So you see how we use the midpoint to find the other endpoint because we already had. So I guess we used the midpoint and the set of xy endpoint that we already had. All right. So that was pretty neat. A pretty neat trick. All right. So you should be able to do 7 and 8 off of that. All right, and do not worry about this. We're not doing algebra. We are in geometry. Let's not do this. All right, just go ahead, do number 7 and 8. All right, and that is midpoint and distance for you.